Welcome back. In this lecture we will discuss hard and soft constraints. So, given a set of variables in a constraint satisfaction problem, we want to assign each variable a domain, and what we've talked a lot about in these lectures is satisfying a given set of constraints. And so if we're required to satisfy a given constraint, that's called a hard constraint. However, we might want to have constraints that we may be okay with it being violated, but we just want to minimize the number of times we violate it, and we may even have a preference over those constraints, and we can encode that by assigning each a weight. And so here we're not looking at just satisfying constraints, we would be looking at optimizing or minimizing the violations of the soft constraints. So a lot of times we'll have problems where it's a mix of both. And let's talk about one such example in the area of class scheduling. So here we have 13 exam days, 52 time slots. We have a whole bunch of students that need to take exams, a whole bunch of sections with exams. We have all these student exam pairs, and we have 274 rooms across 38 buildings. So the number of variables that we got is we need to think about every time-place pair where an exam can occur. And so we would have time slots by rooms would be the set of variables. So it would be time slots by rooms. So it would be a pair of those. Specifies a unique time and place for an exam. So then what is the domain? Well, each of those time slot location pairs can have one of 1,700 exams. So each exam, could be the domain value. So how many total assignments are there? So we have these, so we have a 1,700, and that is going to be raised by the number of time slot room pairs. So it's going to be 1,700 times 50 to the 52 times 274. So we have a very large search space because we have all these exams. They all have to go somewhere, and each of them can have a lot of potentially different values. So what are the constraints? Well, we can't have one time slot room pair that has multiple exams happening in the same room at the same time. So that's an obvious one. We have to make sure that students who are in multiple classes perhaps can't, we want to maybe not allow a class or two classes that a single student is taking to have both exams at the same time. So there can't be more than 30 conflicts for a section. So we could resemble this as a hard constraint. So maybe instead of not allowing any student to have two exams at the same time and location, for each section we want to limit that total to be no more than 30. We also want to consider allowable times for each exam. Certain courses may want more time because they have, they're weighted with more credit hours or something like that, so we would maybe want to account for that. Allowable rooms for each exam because different sections are going to be of different size, and some may require a bigger room or even multiple rooms. Requested room features for each exam. So if we are doing something that maybe requires video equipment or something like that for the exam, or some kind of software to monitor the students in the room, we have to consider that as well. Unrelated exams cannot share a room, which is one we talked about. Cross-listed courses may have the same exam time. So if we have a course that, let's say, is cross-listed for both computer science and EE, that would actually be permitted. Evening courses must have evening exams to account for things like students who are working during the day. And what are we trying to minimize? Well, we want to avoid as much conflicts as possible so students don't have to reschedule an exam. We want to keep students to have, we want to minimize the number of students who have more than 2 exams in the same day. Students with more than 3 exams in 4 consecutive days would be another thing by policy perhaps we'd want to minimize. Students with back-to-back exams, because you're not giving students time to take a break. And students with less than 8 time slots between exams, because we want to account for study time. Preferred times, some teachers might have preferred times for a given exam, preferred rooms, and so on. So all these different things would be soft constraints that we would maybe have a preference over if we're going to minimize it or not. As you can see, this becomes a very complicated problem very quickly. The idea of having a CSP that considers both hard and soft constraints, minimizing the soft constraint violations while also ensuring that the hard constraints are met, is very important because these problems can grow very quickly, and as you could see, the search space also can be quite huge. So that concludes our introduction to hard and soft constraints. Please stay tuned for more content.